Hello and welcome to Carl & Cymru. My name is Mr. Mackenzie and I'm here to go through A2 statistics. Unfortunately, because the recording didn't work last night, I am recording the questions that I was going to go through now. Video. Mr. Weatherhead has also going to be recording the mechanics side, so he's going through a couple of mechanics questions so that you can download and have a look at your own sort of choice. And as we say with all of these videos, what you can do is you can pause the video, you can try the questions yourself, and then you can look through them so you can see exactly what the question is asking for. So with this A2 video, the two questions or the two topics that I went through was the continuous uniform distribution and the normal distribution. What I thought I'd do here is just a quick recap on the uniform and the quick recap on the normal so that you can make sure that you've got a good understanding of what is required. So with the uniform distribution, we would say that X belongs to U and its parameters are A and B. What they would look like in a diagram would be block like so. There's A and there's B, and the probability is B minus A. And the area of this rectangle is going to equal 1 because this is the probability of the value itself. Another sort of hint or reminder is that if they ask you to look for what is the probability of a specific value, it's going to be 0, because to work out the area, you're going to need to work out the area. So you need, to work out the probability, you're going to need to work out the area of this part. So if it's just got a one sort of notation, one value, then it wouldn't have a width. With this, then, how we would go about writing it would be that f of x is equal, has a probability of 1 over b minus a between a and b, 0 otherwise. And then the other two sort of elements would be the expectation, which is the mean, which is a formula in the formula booklet, which is a half b plus a. And then the variance, and if you remember that if you were to square root the variance, you would have the standard deviation, or at least the positive square root of the variance is the standard deviation. And the formula of which is 1/12, and then is b minus a all squared. Both formulas, as I said to you before, are in the formula booklet, but they're there sort of to help you. Next, we move on to the normal distribution. And then we have the normal distribution like so. So you've got this bell-shaped curve, and the bell-shaped curve can be seen in, it's a little bit skewed, but you get the general idea. And the bell-shaped curve can be seen with histograms or it can be seen in data. What you're going to be looking for is that the central point is the highest point, and then it reduces down in size as it goes outwards. That bell-shaped curve is basically the normal distribution with mu and standard deviation. Okay, and then what happens is mu is the mean, and what happens with the curve, if you were to increase, so if you see my hands as like the bell, if you increase the mean, it just means that it moves along the positive x-axis. If you decrease it, then it moves along the negative x-axis. With regards to the standard deviation, because the area underneath the curve is equal to 1, what happens is if you were to increase the if you were to increase the standard deviation, so it gets tighter and the height of the bell goes higher. And then if you were to decrease it, it gets wider at the bottom, so it brings down the height of the bell-shaped curve like so. Okay, and what I've also said as well, the best way to sort of calculate with the normal would be to use the calculator. Okay, the white calculator, if you go to menu 7, you've got 3 different options. you've got the normal PD, which is the specific value of the normal. You've got the normal CD, which is the cumulative value of the normal, and then you've got the inverse normal. I'll be going through or using them as we go along. The formula, if you want to use Z, where Z belongs to a normal of 0, 1, and that's when you're looking for the inverse, and then we use the symbol I to -1. Not I, sorry, that'll be thigh, the -1. The formula is Z equals X minus mu over the standard deviation. Okay, and then what would happen there is if you were trying to find out the mean or the standard deviation and you didn't know what, you knew what the area under the curve was, and then you could rearrange it and work through it like that. Okay, so I'll be using one of those. Also, when you're doing the CD, not the inverse, sorry, not the inverse, the normal CD, the cumulative, you've got to remember that you are asked for 4 bits of information. The first one is the lower point, then it's the upper point, then it is the standard deviation, and then it's the mean. If you're asking for greater than, your lower point is that value, and the upper point needs to be 1 times 10 to the 99, because you're looking for the rest of the area of the curve. And then if it was the upper point you're looking for it to go down, then it'd be -1 times 10 to the. Okay, I've got 3 questions that we can go through now, and they are number 1. So it's continuous. The continuous random variable x is uniformly distributed over the interval of 1d. So it starts at 1, it goes to d. D we don't know anything about. The 90th percentile of x is 19. Find the value of d. So now we've got a bit of information. I'd probably recommend drawing it. So here, this value here is 1. This goes all the way to d. This then is 1 over d minus 1. And then this part here, which we said is 19. And now area, all of this, is equal to 0.9. Okay, so if we were to put that in form, then we would have that the area is 0.9, and that would be how we'd work that out. The width, so it is 19 minus 1 times the probability, 1 over d minus 1, and that is equal to 0.9. So now we have 18 over d minus 1 equals 0.9. 18 divided by 0.9 equals d minus 1. This is 20 equals d minus 1. D is equal to 21. So now, so this is part A. So for part B, we can say that x belongs to the uniform, and it is 121, because we've just worked out d as 21. So part B is calculate the mean and the standard deviation. So if you have a look, I remember that the expectation is equal to the mean, which is equal to a half b plus a, which is a half 21 plus 1, which is 11, because a half of 22 is 11. And then the variance is equal to 1/12 b minus a squared, so it is 1/12 21 minus 1 squared, which is 400 over 12. That's the variance. So to work out the standard deviation, you would square root 400 over 12 to give you an answer of 5.77 to 3 significant figures. Okay, and then that would be that question answered. Next question is a normal question. So, and look at the marks, it's there, 8 marks. A bakery produces large loaves with masses in grams that are normally distributed with a mean, mu, and variance of delta squared. It is found that 11% of the large loaves weigh more than 805 grams, and that 20% of the large loaves weigh more than 795 grams. Sorry, weigh less than. So if we were to sort of look at those in a diagram, so 805 is going to be the top end here, and would be that region there. But the calculator, when we do the inverse, is not going to be able to work out this sort of side. So what we do is this point here, we say as 1 minus 0.11, which is equal to 0.89. For the other one, it's going to be down here, so that's fine. That is going to be 0.2. Because we don't know the values of mu and the standard deviation, because let's be honest, that's what we've been asked to work out, we're going to have to use Z, which is for the normal 0, 1. These are the sort of standardized values. So once we've used Z for n equal to 0 and 1, let's do the first one. I phi of 0.89 is equal to, so on the calculator you would do menu 7, 3 would be inverse normal. You would type in for the standard deviation 0, for the mean 0, standard deviation 1, and for the area 0.89, and equals, and it'll come up with a value of 1.2265. And you need to write it to 4 decimal places because you have to be as accurate as possible. And then for the other one, so phi of 0.2, and that is equal to minus 0.8416, which is expected because we have put in a mean of 0, so therefore if it is less than that, it's going to give a negative value. So now we've got our 2 values of Z, we would use the formula that I said before, where Z is equal to x minus mu over the standard deviation. So we would have 2 simultaneous equations, 2 equations that are set up with 2 unknowns, so it's going to be simultaneous equations. For the first one, it is minus 0.8416 equal to 795 minus mu over delta. For the other one, it is going to be 1.2265 equals, and that would be 805 minus mu over delta. Now how I would do it is I would replace the delta and the 1.2265. That goes up and that comes down, same with this one, and then you've got delta. So what we're actually doing is equating each of these values. So it would be 795 minus mu over minus 0.8416, and that is equal to 805 minus mu over and then 1.2265. The reason why I've kept these values as they are is because I want you to see the level of accuracy that I need to sort of bring in. So then these will cross up so that we have nothing on the bottom. So it would be, I'm just looking at these, so the 1.2265 comes over here, so it's going to be 975.0675 minus 1.2265 mu, and then on the other side it is going to be minus 677.488 plus 0.8416 mu. Then obviously you would take this minus 677.488 over the other side and the minus 1.2265. You know how to do all this. So what we would end up with is 2.0681 mu to 1652.5655. So mu, by bringing that underneath there, would be 799. So we've now worked out what the mean is. So what we have to do next is to work out the standard deviation. So the standard deviation, I would pick the second equation because I think it's a lot sort of nicer to use. And draw a line down here so that you can see that it is on a different part, so that we have standard deviation is equal to 805 minus 799 over, and then we had 1.2265 by dropping that underneath, so that the standard deviation is equal to 4.89 to 3 significant figures. I've got one more normal question for you to do. And then that is, so a company, and this is also taken from WJC. I thought I'd take all the questions from there for the purpose of this, so you get used to the language. And the other thing I was going to say to you is, remember now, there is a lot of reading in these, so you have to be quick and you have to be accurate with what you're doing, okay? A company produces kettlebells whose weights are normally distributed with mean 16 kilograms and standard deviation 0.08. So the first thing I always write is X belongs to a normal, and it is 16 0.08 squared, because the standard deviation is the 0.08 and this is the variance. We write it like this so you can just pluck the figure out. Find the probability that the weight of a randomly selected kettlebell is greater than. So you're asking for probability X is greater than 16.05, and then again that you would put into the calculator, where it would be menu 72, so it's CD, and then you would have lower bound 16.05, upper bound 1 times 10 to the 99, or a really large number. You have the standard deviation at 0.08, and then you have the mean at 16. Do not get those two mixed around, okay? Have a look at the way in which it's written in the calculator. It's slightly different than this. Then you should get an answer of 0.26599. That's that question done, which is, if I label that as part A. Part B, it says the company trials a new production method. It needs to check that the mean is still 16 kilograms. It assumes that the standard deviation is unchanged. The company takes a random sample of 25 kettlebells. That's important, okay? The kettlebells, how many you've sort of done, or how many have been checked. Okay, normally part C of this question, but I've excluded it now for the purposes of, we haven't gone through it, is hypothesis testing. So we're just looking at the normal element, but hypothesis testing would have come in part C. It decided to reject the new production method if the sample mean does not round 16 kilograms to the nearest. So what's happened now is our random variable with this sample, so if you want, you don't have to, you can call it something else because of the fact that it's a sample, has got 16 kilograms as its mean, but the standard deviation has changed. It's now 0.08 over 25, and that bit squared because of the fact that it's the variance. The 25 hasn't been squared because that's there, but when you put it into the formula, you're going to have to make sure. And the formula for which, well, you don't need to worry about that because that is just going to go into the calculator. But for the hypothesis, that's something you need to make sure you look at. So find the probability the new production method will be rejected if in fact the mean is still 16. So basically this is 100 grams to the nearest. Remember doing it at GCSE, so it's upper and lower bounds. So if we were to write 16,000, because that's in grams, and then half of that is 50, so that's going to be your upper bound. Half of that is 50 again for the lower bound. So that the upper bound is going to be 16,050 grams, which is 16.05. And then the lower bound is 15,950 grams, which is 15.95. So we want to know, find the probability method is rejected. Well, it's only rejected if it's outside of these regions. So then we are looking at the probability of rejected is equal to 1 minus the probability that it lies between 15.95 x and 16.05. So when we put in the calculator for the normal, we do 1 minus and then calculate for the normal. We've got a lower bound of 15.95. We've got an upper bound of 16.05. We have, so if I go upper bound of, lower bound of 15.95, upper bound of 16.05. Our standard deviation now is 0.08 over the square root of 25, and our mean is equal to 16. That's important that you put that element in. When you put that into your calculator, you will have 1 minus all of this, dot, 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 1 minus the probability. If I put probability of 15.95 x 16.05 and have an answer of 0.00178. That would be the probability of it. Okay, thank you very much for all your support this year with Cal and Cymru, and please go to the website to see if there are any videos that will help you for your revision. Thank you.